This is 8.3, 8.4, part 3. We're just going to finish example 5 from this lesson. So we had drawn our goalposts A to B, 1.8 meters, and then we labeled this part over here the player C. That would make the 1.8 meters side C. This would make the 4 meters side A, and then the 4.3 meters side B, because it's opposite of those angles. And we want to know the angle between the puck and both goalposts. So this angle over here, which is angle C. We can call it theta or angle C. We can also call it X, doesn't really matter, but that's angle C. So we're looking for angle C, which is theta. Theta is just a Greek letter. I could have said A, could have said B, could have said C. If I am choosing a regular letter, a letter from the English language, then I would have called it angle C, uppercase C, because it's located at vertex C. So we have a contained angle and two known sides. So I'm going to use that cosine law. I'm going to approach it a little bit different from the question above. I'm going to first write out the formula and then isolate for the angle formula, and then I'll plug in my numbers last. So in other words, I'm looking for angle C, so that means I need to have the C squared version is equal to A squared plus B squared minus 2AB cos C. And so what I'm going to do is I'm going to send this to the other side and this to this side. So I'm going to get 2AB cos C is equal to A squared plus B squared minus C squared. So I'm bringing this whole term over. So when I bring the whole term over, I just change the sign at the front to make it positive. And this, I'm bringing that on the other side, so I make it negative. And if I want to get cos C alone, I'm going to do divided by 2AB on both sides. And so I get cos C is equal to A squared plus B squared minus C squared over 2AB. Now, what is important here is that we realize we want to find angle C, which is theta. So to find angle C, we have to do angle C is equal to the inverse cosine of A squared plus B squared minus C squared over 2AB. And so assuming you named your triangle properly, you labeled your triangle properly, now it's a matter of just plugging in the information. So if you had more room, you would continue downwards. I'm going to continue over here. So theta, which is angle C, is equal to the inverse cosine of A squared. So A squared is 4 squared plus B squared, which is 4.3 squared, minus, open brackets, make sure you do that, C squared, so 1.8 squared, over 2 times 4.0 times 4.3. And so let's figure out what those numbers are. So we have 16 plus 4.3 squared minus, open brackets, 1.8 squared, close brackets. So we get cos negative 1 is 31.25 over 2 times 4 times 4.3 over 34.4. And so we're going to round once we figure it out. So let's see, we have 31.25 divided by 34.4. Let's do the inverse cosine. And we're going to get 24.71. We'll round to the nearest degree. So we get about 25 degrees. Therefore, the angle between the puck and both posts is approximately 25 degrees. So what I did in this situation here is I isolated for the formula for the angle. And again, if you had a different angle you were looking for, you just swap the letters around. And then I just took the numbers from the actual triangle here and plugged them in and did my inverse cosine. Make sure that your calculator is always in that degrees mode all the time. And that's how you would solve another problem using the cosine law. So again, know the situations where you would use a cosine law. If I ask you to solve the triangle fully, you need to make sure that you find all components. For any word problem, make sure you start off with a sketch and then show me what you're looking for, write your formulas down, rearrange if you need to, and then plug in your numbers. And that there is the last example for the cosine law. In the next video, we're going to see some mixed problems involving a variety of different tools that we learned about. So the cosine law, sine law, and also the trig ratios.